Hi friend, Pradeep Vaikar is here. Welcome to my channel Stampsbee. Today we are meeting in session 4 of Deep Draw Operation Gap Analysis series. In today's session we are going to understand fourth area of the series, which is production setup approval of sheet metal draw operation and its desired technique. And friend, in today's session I am going to publish standard gap analysis template for sheet metal draw operation setup. With the help of this pre-filled template, you can easily verify and approve draw operation setup in your industry. Link to the template is provided in description box. And friends, if you have joined this channel for the first time, please subscribe to my channel and press bell button. Also like and share this video with your friends. It will motivate me to make more and more video. Come on friends, without any further delay, we will start session 4. The performance of the draw operation depends on the entire drawing process conformity. To map the whole drawing process, I have applied SIPOC process mapping tool on the drawing process. Table 4.1 shows the mapping result. Column S shows the names of the input suppliers who supplies the input to process, such as raw material, equipment and lubricants. Column I shows the process input such as production plan, component drawing, control plan, draw die, production press, raw material, die clamping work instruction, lubrication work instruction, lubricant and handling pallet. Column P shows the process steps such as draw die readiness, press readiness, raw material readiness, die installation, operation setting, quality approval, setup approval, batch production, intermediate approval and setup change. Column O shows the process output such as accepted drawn panels, first part inspection report, thinning inspection report, intermediate inspection report, production report, stepwise approval report and final setup approval report. Column C gives the name of the customer who buys the product, such as internal quality team and BRW team. Coming back to process, in every process step, input is converted to output by adding some value. All process steps are sequentially connected till the input is converted into the final output. In next part of presentation, we are going to discuss all these steps in detail. Process step 1 is draw die readiness. Table 4.2 gives the major process checkpoints such as draw surface condition. It should be free from pitting and material deposition. Draw surface hygiene. Draw surface should be free from dust and contamination and it is in wash condition. Gas spring condition. All gas springs should be available in working condition. Gas spring pressure. It should be at mean value of the pressure window, that is plus minus 10% of the proven pressure. Working element condition. All working elements should be in working condition. Process step 2 is press readiness. Table 4.3 shows the major process checkpoints such as press tonnage. It should be as per the home line tryout. Press type. It should be as per the specification provided by the die designer. Press parameter. They should maintain within specification and monitor on weekly basis or as and when required. Press functional points. They should monitor on daily basis and recorded. Multiple cushion operation. They should operate in synchronized way. Process step 3 is raw material readiness. Table 4.4 shows the major process checkpoints such as RM procurement. It should be from the approved source mentioned in raw material quality plan. RM chemical, mechanical properties and Y to T ratio. It should be maintained within the specification limit mentioned on raw material quality plan, and Y to T ratio should be as per the HLTO trials. Raw material size, thickness should be maintained within the specification limit, and width and length should be maintained at plus side of sharing tolerance. RM surface quality, it should be free from the surface defect. RM packaging, it should be as per approved packaging scheme. RM age, it should not be more than 6 months at the time of RM dispatch. Process step 4 is die installation. Table 4.5 shows the major process checkpoint such as cushion pin length. It should be maintained within plus minus 0.5 mm with respect to the specification. Next point is cushion pin layout. It should be maintained as per the specification provided by the die designer. Figure 4.1a shows the specification provided by the die designer. Figure 4.1b shows the missing pin. It is a process non-conformity. Die loading position. Die should be loaded in the center of the press or specification given by the die designer. Number of the clamping points. All clamping points should be fastened as per the clamping work instruction. Figure 4.2a shows the standard clamping practice, and figure 4.2b shows the non-standard clamping practice. It is a process non-conformity. Clamping accessories. Standard clamping accessories should be used. Figure 4.2a shows the use of standard distance block and standard length of the stud, whereas figure 4.2b shows the use of non-standard distance block and longer stud. It is a process non-conformity. Step number 5 is operation setting. Table 4.6 shows the major process checkpoint such as RM stacking distance from the operator position. It should not be more than the optimal shoulder grip length, that is 665 mm from the operator position. In figure 4.3, it is denoted by letter A. Next point is RM stacking height. It should not be more than the optimal elbow height, that is 1005 mm above the ground level. In figure 4.3, it is denoted by letter B. RM loading pallet. It should be as per the approved logistic sheet. Input blank lubrication. It should be as per the lubrication work instruction displayed on loading station. Die setting height should be maintained within plus minus 0.03 mm with respect to specification. Figure 4.4 shows the die setting method. Die shut height is set and measured on a piece of lead smashed between the setting blocks. In figure, it is denoted by letter H. Next point is drawn part stacking distance from the operator position. It should not be more than maximum shoulder grip length, that is 715 mm from the operator position. In figure 4.3, it is denoted by letter C. Drawn part stacking height. It should not be more than the maximum elbow height, that is 1180 mm. In figure 4.3, it is denoted by letter D. Last point is unloading pallet. It should be as per the approved logistic sheet. Process step 6 is quality acceptance. Table 4.7 shows the major process checkpoint such as visual defect inspection. First part should be inspected for visual defect like wrinkles, crack, thinning, skid line, shock lines. In session number 5, we are going to understand all these defects in details. Next point is thinning. First part should be inspected for the thinning percentage with reference to the percentage given in control plan. Next point is dimensional defect. The first part should be inspected for the dimensional defect by verifying the bottoming marker depth with respect to the bottoming mark depth on master panel. Process step 7 is setup approval. Table 4.8 shows the major process checkpoint such as setup approval method. The cross-functional team of quality and press shop should verify the earlier step approvals and give final approval for the batch production. The approval should be in written format. Process step 8 is batch production. Table 4.9 shows the major process checkpoints such as multiple handling pallets. The press shop should have multiple handling pallets to accommodate the batch produced. Next point is monitoring of the process parameter. The process owner should monitor the process variable such as cushion pressure, input material and lubrication throughout the process. Process step 9 is intermediate quality acceptance. Table 4.10 shows the major process checkpoint, that is intermediate and last part inspection. Intermediate quality inspection should carried out as per the frequency set in control plan. Last drawn panel should be stored in draw die for the reference of next production. Process step 10 is setup change. Table 4.11 shows the major process checkpoints such as drawn part parking. Batch produced should process to next operation immediately, or suitable parking area should available for parking drawn panels. Clamping accessories parking. Dedicated parking area should be available for parking of clamping accessory. It will eliminate the surge time in the next loading. Die parking area. Dedicated parking area should be available for parking the draw die. Table 4.12 shows the sample gap analysis template for setup approval. In this template, some sample data is filled for your reference. It may be different from organization to organization. In this template, first three columns, element in area, sub-element and desired state of the element, form a setup approval checklist. It will help you to approve setup in your industry. Link to Excel template is provided in description box. And friend, this is the last topic of the today's session. Today we have covered the fourth area of deep draw operation gap analysis series. For clear and detailed understanding of deep draw operation gap analysis, please check out the earlier sessions of the series. The links are provided in description box. And friends, please write your doubts and suggestions in comment section. Below are the links on which you can connect me. See you again in the next video of gap analysis series. Thank you for watching. Bye bye.